Well, hello and welcome to episode number 41 of the Wondrous Stuff Vodcast, and now podcast, broadcast live on Google Hangouts on air every weekend. This is the place where you'll find news, information and commentary on any science, engineering and technology subjects from the past week and beyond, and anything else that interests us from inside our tiny little human brains. Now, my name, as ever, is John Gardner, and to help us out on this journey to knowledge, let me introduce my colleagues of standing in the field, outstanding in the field. Richard Smith and Ross Davidson. Say hello, chaps.
Hello, chaps.
Jolly good. Right, we're going to kick straight on with the topics of this exciting, scintillating episode. And this first topic is Richard's, and he's going to talk about something that is topical, and also has been on mainstream media, because I think we've all heard this this week, and it is about Alzheimer's disease and whether it is contagious.
Yep, I must confess that I haven't done a great deal of reading beyond a mainstream report, so you guys probably know as much about it as I do, but for the benefit of those who don't, the headline that is captured the story is Alzheimer's contagious? Now, the answer to that is still no. However, there is reason to be alarmed or cautious when it comes to surgeries, because basically what they found is patients who have Alzheimer's have clumps of basically sticky material made from protein fragments. These are called beta amyloids, and in the 70s and 80s, people were given hormone treatment, pituitary hormone treatment, and a lot of those people have gone on to develop Alzheimer's-like symptoms far before they would have done normally, so at an early age, and also they've not developed full Alzheimer's, just the symptoms of Alzheimer's, and then died of it. Creutzfeldt-Jakob disease.
Creutzfeldt-Jakob disease.
That's the one. So that's what they've been looking at. So 8 patients who'd received the growth hormone. These were children with stunted growth before 1985, when it was stopped. So the individuals are now between 36 and 51, and none carry the gene variants that bring about early onset of Alzheimer's.
So this is this genuinely Alzheimer's, or is this Creutzfeldt-Jakob disease?
Well, it's Alzheimer's basically. It's Alzheimer's-like symptoms in people who have this disease. So it's people who've died of CJD.
CJD.
Yeah, after being treated by growth hormone, and they've developed brain changes seen in Alzheimer's.
So this is interesting, because obviously we all know CJD to be what the outcome of eating meat that was fed its own species in the 90s, wasn't it? 80s, 90s. So I didn't think there was any other cause of this. So you're saying that this pituitary experiment...
Well, even that, even are you talking about BSE there?
Well, BSE was what's in cattle, and that was... Yeah, when it went into humans. The human form is CGD, isn't it?
Well, even the origins of that are still... I was doing a bit of reading on that as well, because that sounded very familiar to me too, and that is the same... is along the same lines. It's a misshapen clump of protein that then gets in and wreaks havoc. And the hypothesis for that was that they were feeding bone marrow and bone meal from sheep to cows, weren't they? And it jumped from a disease in sheep that was something totally different. It jumped and became BSE in cows, and then jumps again and becomes.
This was because what they thought, and as far as I was aware, this was still the case, perhaps it isn't. But they thought the reason why it got into the human food chain was because the meat still had well, it was brain tissue or spinal cord tissue.
That's right. And in all countries where they've introduced regulation to separate out at abattoirs to separate out the brain and spinal cord and other contaminated parts that have these protein folds in them, in all developed countries that have took those measures, they've all seen a fall in the instance of this. So that does seem to be a strong causal link. But yeah, so basically, out of the 8 people that they studied in this study, they had an unusual buildup of this protein, which has long been linked to Alzheimer's disease. None of them developed Alzheimer's and had any other brain changes linked to the disease, but had this particular pattern of basically it causes like micro holes in the brain, which eventually leads to death.
Which is that BSE was spongiform, wasn't it? Because the brain went spongy, and that's exactly what it is.
Yeah, exactly. Yeah. And of 2,000 men and women who had these injections for stunted growth, 77 of those have died from CJD. So really, how you get from that? I mean, that's what it's all been about. How you get that from that to surgical instruments, I'm not quite sure, but that's the worry, is that if these protein folds can be transmitted, we know that they don't, that they can survive sterilization with formaldehyde. So I guess that's where it's coming from. They know that this has been transferred by these injections, and we know they can survive sterilization with formaldehyde, and that's what we do with our instruments. Could we potentially be transferring these misshapen proteins into healthy people?
I was under the impression that the NHS sterilization, because all of the equipment that's used in the NHS goes to one big place, and I've seen it on television before, and they're all in sort of like obviously because it's contaminated material coming in on instrumentation. And I wasn't aware that they were using formaldehyde. They seem to use lots of other things. They seem to bake them in very high temperatures as well. So there's like a mixture of things. Yeah,
and also the blades and stuff are disposable, of course. But it's things like when you go for a root canal at the dentist, even that could potentially be something where. But basically, the authors of this study are not trying to ring alarm bells, because that's the job of the tabloid newspapers. They're just saying this is cause for concern in the medical community, and that's who the paper's aimed at, not the public, and should be investigated further. So they're calling for a study on surgical instruments next. So that isn't what this study is, but obviously that's what the news reports was about.
Yeah.
So they've said in their conclusions this is where it should go next, and instead of running with this study, the papers have ran with, could there be a link with surgical instruments, and that hasn't been tested and looked at either way. I know somebody on Radio 4, I don't know who it was, some chief medical officer or something or other, came on and said absolutely not, that it can't be transferred that way. But as far as I know, there hasn't been a full comprehensive scientific study done yet to find that out.
But if it was the chief medical officer of the government, then they will stick with the party line until they know something categorically.
Yeah.
So even if they have suspicions...
But it's dangerous to say that something's safe if it then gets proven not to be safe, isn't it?
Yeah, well...
I suppose you could still fall back on current understanding. There's no evidence, therefore it's safe as anything else without evidence. But yeah, an interesting one. What I was going to talk about this week was the, which I didn't have time to prepare for to do it justice, was the human ancestor discovery that's been made and the bodies that they've uncovered, which is a huge one. So maybe I'll leave that for next week.
Oh, is this this separate sort of human-like species?
Yeah.
Yeah, I did see about that, and I saw they did a mock-up of the caricature of the face and everything, and it was the whole bone structure was distinctly different from like Homo sapiens and other Neanderthal type.
I'll tell you why I didn't do it is just because I've done so many of those type of stories recently, and it only broke on Wednesday or Thursday, didn't it? So I've just thought I need a bit more preparation time to do it justice, and also I've just kind of done it, so I might do that next week.
Interesting. So good topic. One in the news, one that it didn't sort of have legs, as it were, in terms of the mass media, because it did. It was only on for about a day. I only heard it in the morning news bulletins.
I think it's because there's nothing more
you can say about it.
The sensational part is the instrument transfer thing, and there's nothing more to that story. So, and that's what everyone seemed to go with, rather than the actual study itself.
But it's interesting the fact that if this is proven, then it's another link. It's another link in sort of in cross species or cross breed contamination, which is interesting.
I should actually say that even the authors of the study have said it's absolutely not contagious. That's not what's being said. It's not contagious. I know that question was being begged, but no, it's not contagious. Definitely not in the way that a virus, like a cold virus, is.
But you are passing contaminants across, and that's the problem.
Yeah, but I suppose in that sense, I mean, cancer's not contagious, but clearly if you spread cancer cells from one person to another, you would be running the risk of something going wrong there.
You can't sneeze on somebody and get Alzheimer's, in other words. Or you can, Right, excellent. Well, we shall leave that one there, and we'll go on to... it's mine, actually. And this topic is quite fortuitous that it's come on today. We've just had the Great North Run in Newcastle, where 57,000 people have run from Newcastle all the way to South Shields, nominally for a good cause, apart from the elite athletes, but normally for a good cause, for some sort of charity. And this story is about how humans, us old humans, are essentially biologically wired to be lazy.
Excellent. I've got an excuse.
Well, yeah, this is what I thought when I saw it, but it's not. I don't think it's genetically wired to be lazy. It's genetically wired to be more efficient. Shall we just say?
That's what I was saying. Instead of being lazy, I'm just being efficient.
So the whole so basically humans have been on the planet Earth for as far as we know about 200,000 years, and a bit of Canadian research, which is published in the Current Biology periodical, which I'll give the link to in the show notes. They did this experiment, and it involved 9 volunteers. And what they got these 9 volunteers to do was they put them all in an exoskeleton. And for those of you who don't know what an exoskeleton is, I shall show you one here. Here is an exoskeleton. So you'll probably seen it before on various technology shows. It enables people who have got spinal injuries to actually get up and actually walk again, because it assists all of their movement, and there's power in there as well. This is not the actual one that they did in the experiment. This is the actual one that they did in the experiment. So you can tell it's not as fancy. It's just at the leg level down here. So what they did, they put these 9 people in these exoskeletons, and these exoskeletons offer resistance when people walk. So the study was about how a person moved, and when you put them in these exoskeletons, what do you think happened?
They moved less.
Well, what actually happened is every volunteer, within minutes of being put in these exoskeletons and starting to walk, they'd all worked out how to modify their step, their gait and their step frequency to expend less energy. Mm-hmm. And basically what the researchers are saying is the findings that this research project came out with was that it's it's essentially encoded in your DNA. It's genetically programmed to have like a feedback loop for things like this, so that
optimization.
yeah, essentially you're rapidly selecting an optimal gait and an optimal step frequency, and this is continually happening. So basically, the way that they did the experiment was they put them in these exoskeletons. They started a metronome off, and people had to walk with the metronome. Now the metronome was out of frequency from their normal walking step frequency, and they were all forced to walk against, sort of like out of their normal comfort zone of walking. And as soon as the metronome was stopped and they returned to their normal frequency, within seconds, they got like a quicker step and a more efficient step, and basically they've worked out that it couldn't be any of the normal sensory feedback loops that they have, which is like a blood gas sensor or a muscle receptor. It couldn't be any of those because it was too quick. It came out too quick, and so essentially the root cause, the outcome of this research is that no matter how long we've been walking one particular way, this could be a year or hundreds of thousands of years, there's a constant biological feedback loop, so that if the circumstances change and a more energy saving way appears, they'll take it like that. We will take the easy option every time. So there you go. So some may say it's lazy, but it's probably just more efficient. And essentially it all comes from our ancestors, where they needed to save their calories for chasing down mammoths and running from tigers and the like. Mm-hmm. And so the least expending of energy is good, because that means you could save it for doing other things when you were being chased.
Yeah. Is this something that would only affect humans, though? Because I mean, I would imagine most animals would sort of naturally have go to the more efficient mode of transport. You know what I mean? If you know what I mean. Like,
I mean, like a cheetah or something like that.
Yeah, I mean, I imagine that if you look at most animals, you'll find that they optimize to their body form, whatever it might be, the least amount of energy expenditure, because it's just a waste. You know, it just seems natural.
Well, I guess so. I mean, I don't know if that's specifically been tested for.
Mm-hmm.
But it would, like you say, it would seem logical that you got. It is not within the body's own interest to expend more than it needs to. In any situation, you have to be the most efficient thing that you do.
It is true of pretty much all animals, apart from maybe some apex predators, where, because the thing is, the very, very top most active predators. So I think evolution, your metabolism and your patterns of behavior are intrinsically linked, and obviously the two forces drive each other. So if you've got a fast-running metabolism, it needs fuel, so you need to constantly eat. So predators like that have to be constantly on the hunt, because they're having to consume however many tens of thousands of calories. And also, it's true of very large herbivores. You know, dinosaurs like Brachiosaurus, but also cows, I guess, and elephants and stuff, where they eat sort of 14 hours a day. They're having to fuel their fast metabolism. So I guess it depends. But for the most, but even those that they're conserving energy, aren't they? Like, there's that little fact about African elephants. They only move along at about 4 miles per hour, but they can charge at 30. But unless they're provoked to charge, they never just do that to catch up. You see the juveniles doing that, but the adults, they fall behind. They just stick at 4 miles per hour no matter what.
Because the adults have learned.
Yeah, because that could kill you. You could go for a run, and then it could come to a stage where, you know, you're 4 miles off getting to food, and you just can't make it because you haven't left enough energy left. So I would guess all animals are wired to only expend energy when it's absolutely necessary.
This has always been one of my little bugbears. Well, not really a bugbear, but you see all these. You see, like I said earlier on, with 200,000 years we've been on this planet, and we've been ever so slowly evolving to our environment as we go on, making things easier. First, we had big heavy things that we put on. Cut down trees and we rolled them, and then we worked out how to do wheels and axles and all this stuff. We've generally been making our life more efficient and easier. And then I always think it's amazing when we get you get all these guys who go off climbing Everest or rowing the oceans and stuff, and it's like you said, we've spent all this time making life easier for ourselves, and you just want to make things harder for yourself.
It's probably a throwback, to say that that's to do with like adrenaline levels. So those kind of people, adrenaline junkies, get less of a thrill from something that you would find quite thrilling. They don't quite get that same hit just because variation's built in. It's that helps evolutionary success. If we all had the exact same drivers, it would put the species at a risk because everyone would take the exact same levels of risk, and that might not be advantageous to the species because you want some people taking big risk, some people taking no risk, and everyone else in between, don't you?
I guess so, but it'd be interesting to know the probability of these people who are taking abnormally large risks to see if they are more likely to kill themselves.
Oh, there will be, but they might also be the people who take mankind to a new island or a new continent because they were willing to take that risk of swimming that body of water where other humans weren't, and that led maybe not to their maybe to their detriment, but to the success of the species. That's the thing. It's the gene, isn't it, that's driving it. It's not really in the interest of the individual necessarily.
Do you not think that was possibly once the case, but now it's just egotism?
Not really, because these things, unless they're evolved out, unless all risk takers are killed, those people go on and have children, and it stays in. That's the thing you've got to remember is there's got to be a pressure to get rid of it. So it has to be sufficiently detrimental to you for it to evolve out, because all those people have to die before breeding age, basically, for that behaviour to cease.
So neither of you two fancy doing the Great North Run then?
You see, this is another something with like the Great North Run. Yeah. Okay, I only do exercise to not make me live longer, but to make the time that I'm living more bearable. So less chance of it, reduce the chance of illness, reduce the chance of having a horrific death. The vast majority, no, I can't say that, but a lot of the people who are doing the Great North Run, because it's so hard to get a place, they'll go with a charity. Mm-hmm. But they're doing it for themselves. They're not doing particularly for the charity. They have to, because that's part of the deal. So I think there's a lot of people out there who are doing it purely for egotistical reasons. So they can say, I did it. Why did you do it? Did it affect everybody? Well, yeah, I did something for charity as well. But I don't think that's the main aim.
Yeah.
So the question was, would you do the? I think no. It's actually pointless for me to do it. I'm not made up to do that length of time, the distance.
How long is it as a half marathon?
It's 13.1 miles. Yeah, half marathon.
Yeah, I could probably walk that.
Could walk it, no problem.
It probably is the activity, interestingly, that humans probably are most geared up for, because we are that over long distances. Nothing can really, when you think about it, there's not many animals can compete with a human over those types of distances. Not 13 miles. Obviously, some animals would have no problem over that. But once you get into massive long distances, humans really can push the envelope in terms of that. And we're kind of up there with the grey wolf, aren't we, in terms of the distances that we can actually cover.
Mm-hmm.
Interesting.
I think it is an interesting one. I think the thing with it is, John, is that I guess if it had longer, more evolutionary time till now from the invention of agriculture, I think you might see more of a difference. But because that's in our evolutionary history a comparatively recent thing, because before that we were kind of just opportunistic, so you had to sort of be on your toes all the time. You didn't know where the next meal was coming from. I suppose from the invention of agriculture, it's given us free time essentially, and then the Industrial Revolution also.
You're absolutely right, and it is an incredibly small amount of time from the agriculture, from the crop rotation, from the invention of agricultural instrumentation and materials, and then the Industrial Revolution. That has just sped things along at such a rate that we are,
and evolution hasn't caught up with that.
Absolutely.
Because everyone's, you know what I mean? It hasn't been it hasn't been a big driving factor in who survives, because everyone's caught up in it. Agriculture has benefited, to different degrees, but pretty much every human's benefited from it now. So I think if you'd had that a long time in the past, or you fast forward maybe a million years into the future, you might see this laziness thing change. But there is some tribes that are still live off the land, and I think they're quite lazy, if you want to use that word. There's the ones who are sort of foragers, because the ones that are still successful to now, basically the food's plentiful. So there's ones that eat these nuts, and they're a complete food source for fat and protein, and then they get everything else they need from berries and things, and they have a very, very sedate life, because once they've gathered it, there's nothing really else to do. So they're not striving to try and do more.
It's possibly because when you ferment some of those berries, they're not in a state to do much else.
Perhaps.
But yeah, I mean things like that. I mean, we are running out of sort of lost tribes that we can do experiment. That sounds really bad. Do experiments with, but to perform these type of experiments where they have been cut off from all sorts of human resources and can you do resources? No, not resources, but human interaction. And it's getting increasingly hard to do that sort of experiment where you can completely fence off from outside influence.
Yeah,
I guess.
Oh, there's very, very few now, isn't there? There's just a handful.
Right, excellent. Well, so there you go. I shall do a little bit of exercise just to keep me from getting morbidly obese. And to make me able to move around more freely, but I won't pretend that I enjoy it. And because I know I'm genetically programmed to make things more efficient and lazy for myself, so there you go. Right, okay. So on to the next topic, and this is a late entry from Ross, and this is about a missing tendon. I have no idea what it's about. You tell me.
Yeah, so this is a missing, well, technically a missing muscle, but there's an associated tendon with it, called the palmaris longus muscle.
So this is the human muscle, is it?
It's a human muscle, and it's in your wrist, but it's missing from 14% of people.
Ooh.
So the first thing to do is see if everyone's got it here. So there's a way of doing this. So what you need to do is you get your thumb and your little finger.
Yeah.
You do that.
Yeah.
And then flex your wrist, and if you look at my arm there, you'll see single tendon come up there.
Oh yeah, you can see what the tendon that just appears poking out.
The one that pokes up when you do that.
Yeah. Got
so
that.
You've got one there.
Yeah.
Yeah. And you do the same in the other arm as well.
Yeah.
Just to check. Everybody got one?
Yeah.
Yeah. Well, we're not among the 14%. So 14%.
Surely that is necessary, and you wouldn't be able to bend your hand.
No. I think you got 5 tendons in your arm there. But that particular single one that pops up when you do that is linked to the palmaris longus muscle. So basically, it's not. If you have it missing, it doesn't affect your grip in any way. it's basically got no apparent function in humans.
Actually, you were right, because it doesn't seem to get particularly taut. It gets enough. It's taut enough so you can see it just bulge through the
it's
skin.
taut when you do this sort of.
But it doesn't seem to pull the.
So it's thought to be vestigial then, basically.
Basically, yeah. They think it performs different functions in various animals because a lot, similar body shape and stuff, different animals. And they think in some animals, like cats, it's used for pulling the skin back to exposed claws. So basically exposing your claws. And it's also prevalent in animals that do a lot of climbing and grab things like orangutans and stuff. But in humans, it doesn't actually help you with grip. And the fact that it's missing in a lot of people, it is something that's vestigial, and unlike sort of other vestigial organs we've got, appendix or whatever, that don't serve a purpose, it's actually missing completely. But one of the interesting things about this is they actually use it for tendon grafts. So obviously, if you have a tendon in your body that needs to be replaced for whatever reason, it's deteriorated or you've injured it, they can actually take this tendon out of your arm and then graft that in your part of your body that's been affected, and it won't actually cause you any bother because you don't use this muscle.
Imagine if you needed a tendon graft and you went in and went, sorry, you're in the 14% that don't have it. You still.
Well, exactly. I mean, I was reading about this, and someone was explaining how to do that, and I couldn't quite get it. There's various sort of videos on medical YouTube videos showing how you test for it, because obviously they want to test before cutting open your arm.
I thought you meant there was medical YouTube videos that told you how to do it. Do the graft, DIY style.
That would be a bit harsh. But apparently there's also a one in your leg as well, which is a similar sort of thing, which is missing in a smaller percentage of people. But I can't remember what it was called, but it was the longest tendon in your body as well. So that's quite handy for this sort of thing. So basically, yeah, it's just an interesting thing that it's something that you think something as significant as a muscle, it's missing in 14% of people, which is quite a large percentage. And talking about things like evolving, it's probably evolving out of humans. If it's not being used, it's probably going to eventually disappear altogether, I would have thought.
Well, it's just like I was saying before, unless there's a pressure for it to. It could actually increase in prevalence, because if it's not hindering or helping either way, and now that we're not really, it doesn't really make much of a difference to our survival, things like that. They say this about various disabilities and things like that. There's no evolutionary pressure for it to go away. Then it probably won't, unless you go around putting a bullet in people's heads who've got it or haven't. Then yeah.
So in terms of sort of things evolving out of, or evolution in general, I suppose, something like the appendix, which is, I'm right in thinking that's called a vestigial organ, isn't it? Because it's not needed.
I think it's got some function, hasn't it? But I think they just think that the cost outweighs the benefit of having it, more or less.
So would there be any reason why something like that isn't missing from humans? Well, I assume it's not missing from any humans. I think everyone has one. Whereas something like this could be missing in such a large percentage.
The appendix is a remnant of what used to be a larger fermenting chamber.
Oh, we used to be able to brew our own beer.
There you go. Like that. But since we've stopped using it we've stopped eating grass and stuff like that, then there's no longer useful. So it is entirely useless now for us.
Unless we decide to go back to grass eating.
Unless we decide to go back to eating grass.
So yeah, but I mean, the reason this interests me so much, and why I wanted to talk to Richard about it, probably more, he knows more about evolution than me. What could be the reason for it being missing in such a large percentage of people? Could that just simply be it's evolved out, or
there's all sorts of
always been like that?
There's all sorts of features in people. I mean, we've talked about like sickle cell and things like that. There's all sorts of features in people that for instance, if you removed everyone, if the African continent was in trouble and you had to move everyone out of that continent into Europe, you would still have people with sickle cell, people without, and unless there was a pressure then to remove it, which there then wouldn't be, it would hang around. So it's all about pressure for it to be removed, and by which I mean it has to be fatal before breeding age to the person with the feature in order for it to make a difference, and that has to happen over a prolonged period of time over the whole population scale. So if pockets of the population it's not affecting them, then once they start interbreeding again, the feature just comes back. That's the way genes work. You'd have to, even dog breeds where you think of like a Chihuahua and a Great Dane being very different, within a few generations of interbreeding, they're back to a sort of a base kind of dog shape, not quite a grey wolf, but a sort of lab type of setup, and they all end up that sort of body plan, because the changes are quite superficial. So it's the same with this. It's a superficial difference, and until it starts making a less than superficial difference, there's no pressure for it to go.
Yeah, I was thinking it wasn't superficial because it's actually a functional. It's not a feature. It's a functional, non-useful, but it's a functional part of your body plan.
It's not serving a survival function. So
right, yeah.
It has to serve a survival function. But even then, of course, change is driven by random chance as well. So, it could be that, all the intelligent humans are on a spaceship going somewhere else because they've made this, they've had a vote and they've made this decision, and then that spaceship gets destroyed and all the, it's a stupid example, but then so you can't really, this could just be chance, you could be the better adapted organisms and be killed by a volcanic eruption through no fault of your own, and the less well adapted ones happen to survive. So there's a lot of that goes on in evolution as well. And with humans, it's just a case that we're across the entire planet now, aren't we? So unless the planet runs into problems, there's not a lot that can happen on a localized level that's going to change our evolution.
So shall we have a little quiz about vestigial bits, body parts and stuff? So can anybody think of the first one, which is different? It's on men and women, but is only useful in women.
Nipple.
Absolutely. Yeah. So for in men, nipples are chest ornaments. Then there's something that's underneath your arms.
Hair.
Yeah, armpit hair.
Does that not channel sweat away from you?
I was going to say, yeah.
No, what they believe is that it was there to hold on to odours that are coming from your sweat glands, but it's your odours. So unless your partner wants a big sweaty whiff of
so these are
not some sort of Ponzi aftershave.
It's vestigial in the very, very immediate last few generations of people's kind of sense then.
Yes.
Presumably that's not in these tribes we're talking about before. Presumably that's not vestigial for them. Maybe that still plays a role for.
Maybe they do want a big sweaty whiff of. Yeah. Well, it's.
So it's used to hold smell in then. See, I would have thought. So you could have it surgically, lasered away then, and you'd be no worse off.
No worse off.
Oh right. I would have thought you would have gotten some sort of chafage, or I thought it would still be right.
I think you'd have sore armpits after a while.
Don't know. So what else is? Oh yes, eyebrows is another one.
Eyebrows?
Yeah, eyebrows.
But how do you express surprise?
You draw them on, like so many young girls seem to do nowadays.
Yes.
They seem to have caterpillars.
Hang on, this is getting daft. If you don't need anything like that, what you could basically quickly go to is, well, you can digitize a person into a computer and the whole thing's redundant.
Well, no, basically they're saying there seem to be two camps for eyebrows. One
it's
believes that
it's rain getting in your eyes, isn't it?
Well, that is one of the camps to stop sweat and rains getting in your eyes, which would supposedly help primitive hunting and navigation. And the other one is what's the other one? For recognition as well. It's supposedly that if you show the same photograph with or without eyebrows, people didn't recognise the one without the eyebrows.
Have you seen that one where they have all the actors without eyebrows? Got all like the really famous Hollywood actors without eyebrows, and they all look absolutely terrifying.
So that's more one where it's got a different purpose from its original purpose then. So it does serves a function, but just not its original one.
Yeah, but I mean, there's two trains of thought in there.
What's the other thought about the eyebrows?
Well, that's one of them says it's just purely functional to stop.
Oh, right, I see what you mean. Yeah.
Liquids dropping down into your eyes and clouding your vision for when you're hunting. When the other one is for the recognition thing. Then there's obviously the appendix, tonsils.
Tonsils.
Yeah. Tonsils, technically part of the lymph nodes, part of the lymphatic system for immunity, but they just sometimes they get inflamed and you can just take them out and they're fine. Everything's fine.
What about the coccyx bone or whatever it is? You know
the vestigial tail on the
vestigial tail.
Yeah.
Only has the function of knacking.
It does not hurt when you hit it when you sit on some. Oh me coccyx.
Yeah.
Wisdom teeth. Wisdom teeth.
I have 3 of them.
I think I've evolved for them because I haven't got any.
You know?
I mean,
I'm missing one for some reason.
I've got 2 still. Teeth don't change size. They're grown, and then they erupt to the surface. But you never actually chew on those right at the back, so they are.
Chew on your mouth with them.
Eh?
I chew on my mouth with them. My 2 that I've got up there every now and then catch my cheek.
Oh yeah, well there you go.
Yeah, so that's one where jaws evolved to be smaller to get the benefits from that, but dropping the teeth hasn't quite happened yet, basically.
Yeah.
But I guess if rather than giving you pain, they killed you, then that's the thing. It would
disappear fairly quickly.
Breeding age, then you would lose wisdom teeth, but because it just makes life unpleasant. Yeah. But we've talked about Alzheimer's. It's similar to that. The reason these diseases persist and they've survived evolution is because they occur in old age and after breeding age, so there's no pressure. So you could say, well, how is it useful to have Alzheimer's? Well, clearly it's not. But until it starts occurring before breeding age, it's no impediment to you passing on your genes. So therefore, from an evolutionary point of view, it doesn't matter.
Mm-hmm. Mm-hmm.
Well, I think that's probably the best time to leave this episode 41. We've come to a natural conclusion of the discussion, and there we have it. Another enthralling episode with topics that, let's frankly face it, never thought was going to come out this week. I thought maybe we'd do another space story, but no, it's not. It's not been all space. It's all been.
They all seem to tie together quite well as well.
Absolutely, it's almost as if we planned it. Which, of course, we didn't. It's completely random. Anyway, what I'd like to say to everybody is, as always, my normal thing, and now I've got my little banner back, I can do this again. We like to hear from you if you're interested in science, engineering, technology, if you have topics that you think we should discuss, if you think that we're wrong on some of the stuff that we've discussed in the past, which is highly likely, to be honest. A lot of this we make up on the spot and just by pure logic and a bit of educational.
It's definitely the case, because I watch myself back and go, that's wrong. No.
But if you say it confident enough, people believe you. It's fine.
Absolutely, you see, it works like that. So if you do think, don't just sit there and get really really angry and then go out and murder somebody. We don't want that. We would rather you get it off your chest and tell us that we're wrong, and we might be able to get you on, and you can vent your spleen. Spleen? No, that's useful. That's
get rid of that one.
We definitely need one of them. So anyway, everybody's got the handle on as always, their Twitter handle. We've also got the email address, which is wondrousstuff@gmail.com. We have on the screen now. We've got the blog, which is wondrousstuff.blogspot.com. I've still got the domain name that I've got to sort out on that, but you can use that for now. This week I've managed to get the RSS feed up and running. So if you have a look on the website, Down here, under the left-hand menu, the last option is RSS audio feed. So you can click on that. You'll get the RSS audio feed. You can open it in something like, I've got Feedly here, and you'll see the last 3 episodes. It'll also work in iTunes. I've tried that today. So why don't you, if you don't like the visuals, if we're far too bloody ugly for you, then you will use some of the stuff that we do every week, because sometimes we use pictures and stuff like we've done this week. But most of the stuff is fine for you to listen to it, and that means that you can listen to it at work and have a good chortle and everything while you're actually supposed to be doing productive work for your boss. So anyway, without any more of ado, I think we'll leave it there for this week. So say goodbye, everybody.
Goodbye, everybody.
Bye, everybody.
And we'll see you next time. Bye-bye now.
Bye.